Welcome to Math with Mrs. Bibb. Today we will be discussing how to solve systems of equations. First of all, we need to define a system of equations. A system of equations is a set of two or more equations with the same variables. There are three methods that can be used to solve a system of equations: graphing, which we will use Desmos; substitution, which you should have learned in Algebra 1; and elimination, which you also should have learned in Algebra 1. All of these you should have learned in Algebra 1. So hopefully this is a review. Because I do need to say something. The point, so your x and your y, of intersection is the solution to a system. The point of intersection is a solution to a system. Next, we want to look at different possibilities for systems. I'm going to go back just for a minute. Now we're going to examine the different possibilities of systems of equations and what those solutions look like. As we look at this first possibility, it says the types of graphs that we have. And when you have a system of two equations, these are the types of graphs you have. The lines can intersect at one point. The lines are identical so they intersect completely. Sorry about that. Or the lines are parallel so they don't intersect. Next, you have types of equations. The equations for the lines that intersect at one point have the same slope and y-intercept. No, sorry. The lines have different slopes. So if the lines have different slopes, they are going to intersect eventually. The lines that are identical and they intersect completely have the same slope and the same y-intercept. And the lines that are parallel and don't intersect, they have the same slope and different y-intercepts. Now when we talk about this number of solutions that they'll have, this type of lines, or this type of pairs of lines, have one solution. They will intersect one time, always. If they have different slopes, they will intersect one time if they're a pair of lines. This number of solutions for the second scenario would be that there would be infinitely many solutions. Since the lines intersect completely, then there are infinitely many solutions. And if the lines do not intersect at all ever, then they have no solution. And then these solutions are described or classified a certain way. If you have one solution, then the system is considered to be consistent. That's because it has one solution. And independent, because it has exactly one solution. Independent. So consistent means at least one solution. We'll write that in a different color. And independent means exactly one solution. And then for the second one, there's at least one solution, so it would be considered to be consistent. And it doesn't have exactly one solution. It has infinitely many solutions, so it is dependent. And always remember this one because they depend on each other. They're on top of each other, the two lines are. So this one means the infinitely many solutions. And the last one, if there are no solutions at all, that means there's not at least one solution, so this is considered to be inconsistent. Moving right along to the next slide. Examples. We are going to classify a system based on its solutions or based on the slope. I don't even really have to graph it or solve it or anything. I can tell just by looking at the equations. So I'm going to classify by doing two things. I'm going to determine the number of solutions and then I'm going to classify it. Now the instructions say state whether the system of equations is consistent or inconsistent and whether it is independent or dependent. So that comes from that previous slide in the chart of the classifications. So here's my system. 2y equals 6x minus 14 and 3x equals 3x minus y equals 7, sorry. 3x minus y equals 7. 3x minus y equals 7. So the first thing I'm going to do is get them both in slope-intercept form. I'm going to divide by 2. So this one would be y equals 3x minus 7. I am going to subtract 3x. Negative y equals negative 3x plus 7. I'm going to divide by negative 1. So y would equal 3x minus 7. So let's compare. Slope is 3, y-intercept is negative 7. Slope is 3, y-intercept is negative 7. So as we look at that, we need to look back at our chart, and they have the same slope and the same y-intercept. So if you look under equations, then you would see that it says in the middle column, the lines have the same slope and the same y-intercept. So there's infinitely many solutions for this one. That's the first answer it wants me to decide, is identify or determine the number of solutions it has. And then if there's infinitely many solutions, to classify it, that means it's consistent and dependent. You do not have to write this next thing, but I just want to talk about something for a moment. If this, and I'm going to get rid of it in just a second, if this had been positive 7, then they would have the same slope and different y-intercepts. They would have the same slope and different y-intercepts, which means there would be, let me grab a pointer. They'd have the same slope, different y-intercepts, which means that they would have no solutions, and then it would be inconsistent. So I'm going to undo that blue. Oh, actually, it's not going to let me do that. Let me erase. It undid my pointer. So let me redo. I'll just erase the blue. So I'll get rid of that. Okay, moving to the next example. I want to solve 5x minus y equals 3. And negative x plus y equals 5. And I want to solve by graphing. So I wish I would have added Desmos, but I believe I can do that here. Not quite sure what that will look like on your end, but that's okay. See if I can move that down. It's okay. I'll just type those in. I'm sorry, I covered up the equations. So 5x minus 3y. No, not minus 3y. 5x minus y equals 3. So this is what you'd be typing in Desmos, because I'm sure you're just watching. And then negative x plus y equals 5. And remember, I said previously that the solution to the system is the point of intersection. And so where do those two lines point, or where do those two lines intersect? And they intersect at 2, 7. So I am going to move this out of my way, I think. Yep. You do not have to draw the graph. When it says solve by graphing, you do not have to draw the graph. You only have to give me the solution. And so the solution is 2, 7. Let's write a little side note here. When it says to solve by graphing, write that as well. When it says to solve by graphing, go to Desmos, enter the two equations, or more. Enter the equations, find the intersection. That's all you have to do. And I will tell you on the SAT, that's all I would do. I would type my equations. If it says solve this system or solve two equations, then I would do exactly this. Go to Desmos, enter the equations, and find the intersection. Although I will be reviewing the other techniques, but you do not have to when you're on the SAT, taking the SAT. All you have to do is find this point of intersection using Desmos. For example 3, we are also going to solve by graphing. The equations are 7x plus 2y equals 16, and negative 21x minus 6y equals 24. I'll pull up Desmos since we're solving by graphing. Type the first one in, 7x plus 2y equals 16, then negative 21x minus 6y equals 24. And let's look at this. What do you notice about those two lines? are they going to intersect? Now they're getting closer and closer and closer, but it's because I'm zooming out. But if I go back, do those two lines ever intersect? No, they are parallel. So what's the answer when the lines are parallel? No solution. And you don't have to draw the graph. Actually, let's draw a rough sketch so you'll have that on hand. And I'll make one look like this. And I'll do green for the other one. Make the other one look like this. And we'll make the note that they never intersect. That's how you know the answer is no solution, because they never intersect. Moving on to example 4. Suppose an electric car cost $29,000 to purchase and almost 4 cents per mile to drive. And a gasoline-powered car costs $19,000 to purchase and 8 cents per mile to drive. Estimate after how many miles of driving the total cost of each car will be the same, which is the point of intersection. So we will do this by graphing. Let's define our variables first. Y is going to be the cost of owning the car. And X will be the number of miles driven. So the equation for the electric car would be Y equals .036x plus 29,000. 29,000 to purchase the electric car, and then that many cents per mile, where X is the number of miles driven. And the electric car is the first one. I'm going to write that because I just got confused. Electric. And now this one's gas. Y equals 0.08x plus 19,000. And this is asking, estimate after how many miles of driving the total cost will be the same. So this is a solve by graphing type of situation. I'll pull up Desmos. Type in the first one. You do not have to put Y equals, but I will go ahead. 0.036 plus 29,000, and then 0.08x. I forgot to put Y equals, but I don't need it. Oh, let's just not put it. 0.08x plus 19,000. So I've entered my equations. Why can I not see the graphs? Can anybody guess why I can't see the graphs? The y-intercepts are so big that I can't see my graphs. So I'm going to zoom in. There's one of them. Let's see, there's the bottom one. Because, there, you see the top one appear. The bottom one, number 2, is green. Number 1 is red. So now I want to find where they intersect, since I can almost see both of them. Now I can see both of them. Now I want to find where they intersect. Should I go to the left or to the right? What do you all think? Would my intersections be in the negative part, or would it be over here in the positive? I'm going to go with positive because they appear to be getting closer and closer and closer. And here we go. It looks like they intersect through here. And I'm zooming in. And it appears. Can you see it's kind of making vertical angles with the red and the green? So it looks like the point of intersection is about there. I don't think it's quite there though. Let me keep going. I think we can get to where we can zoom in and we can actually find that point of intersection, and that's as far as it's letting me go. And that's still where it's saying that they intersect. So I think that's the perfect intersection. 227,272.7 miles. 37,181.8 miles. Okay, so I'm just going to click to the side here so I can move that graph out of the way. So, which one of those represents the cost? The question is, estimate after how many miles of driving the total cost of each car will be the same. So the total cost being the same is your Y, because the Y is the total cost. So the total cost is the same when we are costing $37,181.82. So the number of miles driven would be around 227,000. I'm going to highlight that. So that's our answer. It says estimate after how many miles of driving the total cost will be the same. So I'm going to put this in a complete sentence. After about, so I'm going to actually round to 227,000. Since it does not say how to round that and how to answer, as long as you were close to that, you would be correct. So after about 227,000 miles of driving, whoops, I put an E, but I know that's an I, driving, the total cost of each car would be the same. And that is example 4. Now we're going to move on to substitution and elimination. Substitution is one equation is solved for one variable in terms of the other. So substitution, one equation is solved for one variable. We'll change that definition I just said a little bit. And substituted into the other equation. Elimination. I do want to say this, there are some great steps in your book on page 107. If you want to write those down, you're welcome to. You don't have to. But if you want to write those down, you're welcome to. But do write that down. And then the definition for elimination is choosing a variable, X or Y, and making the coefficients the same but opposite. That means the same number but one positive, one negative. Put like positive. Couldn't do that at the same time. The same but opposite, one positive and one negative. And adding, I always add, I never subtract. You are welcome to subtract, but I always add adding the equations together. This actually only solves for one variable. You'll have to substitute to find the other variable. Let's do some examples. Number 5. We're going to solve using substitution, and that equation is 8x minus 3y equals negative 1, and x plus 2y equals negative 12. The best advice that I could give you is to, if at all possible, to pick a variable that does not have a coefficient. So if at all possible, pick a variable that does not have a coefficient. And on this one, I do have a variable that does not have a coefficient. So I am going to solve for that variable, which means I'm going to get x alone. I'm going to subtract 2y. X is going to equal negative 2y minus 12. Then what you do is you substitute this expression into the other equation, and I would strongly suggest using a highlighter here on your notes. If you need to borrow one, you're welcome to borrow one. So I'm going to rewrite this top equation as 8 instead of x. I'm going to put negative 2y minus 12, and then everything else stays the same. I'm going to distribute, combine like terms, add 96, and divide by negative 19. Y will equal negative 5. Immediately, I write an ordered pair and put negative 5 in the y spot and put a box around it, because that's going to be my solution. And now I substitute to find the missing answer. The best place to substitute, you can substitute anywhere there's a y, but the best place is to go back to right here and substitute there. So x equals negative 2 times negative 5 minus 12. So x equals 10 minus 12. X equals negative 2. So the solution to that system is negative 2, negative 5. My next example, number 6, I'm going to use elimination, and I'm going to solve negative 2x minus 9y equals negative 25. With negative 4x minus 9y equals negative 23. When I do this, I am going to look for coefficients that might already be the same. So as I look at this, I see these two are already the same. But I want them to be the same but opposites of each other. They are actually the same. So I want one to be positive and one to be negative. And you can choose whichever one you want to be positive. I'm going to make the bottom positive by multiplying everything by -1. And I'm going to multiply the top by +1. So that means the top equation will not change. -2x minus 9y equals -25. And the bottom equation will become positive 4x, because you distribute -1 to everything, plus 9y equals 23. Then I'm going to add them together. -2x plus 4x is 2x equals -25 plus 23 is -2. Divide by 2, x equals -1. Immediately I put a box and put -1 as my solution for the x, and then I know I'm not finished because I have a blank there for my y. Then what I would do to find x is substitute. Pick a spot where there's an x and substitute it in. I'm just going to put it into the top equation. It does not matter. Substitute, do the multiplication, subtract 2, divide by -9. Y will equal +3. So -1, +3 is the solution. Moving on to the next example, I am going to use, I don't know, I'll show you the example and then we'll decide. I have 2 left. I think we'll do elimination with this next one and substitution with the last one. And I don't know. We'll see. Okay, so number 7, 2x plus 5y equals 1, and 3x minus 4y equals -10. The reason why I would not pick substitution for this one, number 1, I don't have a variable that's alone. I have coefficients on everything. Number 2, if I divided everything by 2, I would get fractions. If I divided everything by 5, I would get fractions. If I divided everything by 3, I would get fractions. If I divided everything by 4, I would get fractions. So let's do elimination with this one. We'll do substitution with the next one, although we're going to kind of encounter that same thing. But that's okay. We'll figure it out. Okay. I want to pick a variable, x or y, and I'm going to use some forethought into this. I'm going to pick y because they are already opposites of each other. One is already a positive and one's already a negative. So I'm not going to have to multiply by a negative number out here. So that's why I am selecting y. I'm going to think about 5 and 4. Think about the multiples of 5. 5, 10, 15, 20. Think about multiples of 4. 4, 8, 16, 20. 20 is the multiple they have in common. So that's how I decide what I'm going to multiply by. What do I multiply 5 by to turn it into 20? That would be 4. What do I multiply 4 by to turn it into 20? That would be 5. Many, many times the least common multiple is what you get when you multiply these two. So you multiply by 5, multiply by 4. Now, it's not always the least common multiple, but you can use that strategy. You can multiply this equation by this number, and you can multiply this equation by this number. That will always work. It's not always the smallest number, though, but it will always work. All right, let's figure out what will be our new equations that we'll get. I am going to get 8x plus 20y equals 4, and get 15x minus 20y equals -50. And I'm going to get 23x equals negative 46 divided by 23. X is going to equal negative 2. So x is negative 2. Now I need to find y. I'm going to substitute negative 2 into the top equation. I just chose the top one because 2 is smaller than 3. So 2 times negative 2 plus 5y equals 1. Negative 4 plus 5y equals 1. Add 4 to both sides. 5y equals 5. Divide by 5, y equals positive 1. So the solution there is negative 2, positive 1. For number 8, here's my equations, I should say. 18x plus 21y. Whoa, that looks bad. 21y equals 14. 6x plus 7y equals 2. All right, let's just dive right in. Honestly, I would choose elimination on this one, but I want to practice substitution one more time. So we're just going to dive in, and I'm going to choose the smallest coefficient. So this is the smallest number, so I'm going to get x alone. I'm going to subtract 7y. 6x will equal negative 7y plus 2. Then I'm going to divide by 6. So x will equal, whoopsie, x will equal negative 7 over 6y plus 1/3. All right, and now I am going to substitute negative 7 over 6y plus 1/3 in for x. So 18 times negative 7 over 6y plus 1/3 plus 21y equals 14. I'm going to distribute 18 over 1 to both of these and do a crash course in multiplying fractions down here at the bottom. So I would write this down. 18 over 1 times negative 7 over 6. I'm going to use the strategy of cross-reducing. 18 and 6 have a common factor. So I am going to divide them both by 6. That would make this become 1. That would make this become 3. So 3 times negative 7 is negative 21. So negative 21y is what I get when I multiply positive 18 times negative 7 over 6y. So I get negative 21y. Now I'm going to multiply 18 over 1 times 1 over 3. I'm going to go ahead and multiply straight across. 18 times 1 is 18. 1 times 3 is 3. I did not do that on the previous one because honestly I did not want to multiply 18 and 7. So if you have a calculator, you could have multiplied 18 times negative 7 and gotten that product, and then 1 times 6 and have that product, and then divide those two. I just did not do that because I don't have a calculator in front of me. And then 18 divided by 3 is 6. So plus 6 plus 21y equals 14. Combine like terms. These are like terms. Negative 21y plus 21y goes away. They make 0. I have no y's left. So I'm left with 6 equals 14. That means this is a special answer. By special, I mean the answer is either infinitely many solutions or no solution. Is this a true statement or a false statement? Does 6 equal 14? No, that's false. So when it's false, the answer is no solution. When it's true, it's infinitely many solutions. And that's the end of our notes. I hope you have a wonderful day.